Listen, Mr.
Let's meet.
All right, we just started a video. We're going over the homework. Sit down. Be humble. What? No, I don't have my. It's at home. Okay, this problem 31B is on the test.
It's on the test.
But of course, the function's going to be different. But you still, it's the same type of problem. You got to prove to me that you can do it. So. Remember, the derivative tells you the slope of the tangent line, and what's the slope of the horizontal line?
0.
0. So we want to know when is the derivative going to be equal to 0. So all you have to do is compute the derivative. Okay, I can do this. You guys got to be able to do this. Lee, derivative. Read it off your paper. Hey, you're exactly what I was thinking.
Cosecant squared plus 2 cosecant plus cosine.
Exactly correct. How many points do you get for that?
5.
I'm not going to give you any for that.
Wait, that's
Okay, so you better know, for this test, you have to know 7 derivatives. You got to know the derivative of x to the nth power, the power rule, and then you got to know the 6 trig functions, and then you better know the product and the quotient rule. Okay, we want to know when is this equal to 0. Now, most students, they don't like cosecant and cotangent, so what did your trig teacher teach you? If you don't like what it looks like, change everything to sines and cosines. So this is -1 over sine squared. You don't have to do this, but most people just feel better if they do this. 1 over sine, cosine over sine equals 0. Multiply both sides by the least common denominator to get rid of the fraction. So multiply both sides by sine squared and you get?
It's already.
What?
It's already.
What?
Isn't it already?
What?
It's already
No,
sine squared.
multiply both sides by. Why do you guys want fractions?
Oh, my bad.
-1 plus 2 cosine x equals 0. I don't know, when I took Algebra 1, my teacher told me if you have a fractional equation, multiply both sides by the LCD so that you don't have fractions in the next step. 2 cosine x equal 1, cosine x equal 1/2. Hey, you somebody! So cosine of what angle is 1/2? You got pi over 3, 5 pi over 3, and there's an infinite number of answers, but you can clearly see that this is the first time to the right of the y-axis, so it's got to be the smallest positive one, right? That's pi over 3. Now it says find the coordinates of the point. We just found the x coordinate. How do I find the y coordinate? You plug it back into the original equation, which for AB this poses a problem, but we're BC, right? Doesn't the original equation give you the y coordinate?
Yeah.
Yeah, so plug pi over 3 into here. Can I let you guys do that? Or do I have to do it? Okay, I'll do it. If you plug in pi over 3 into the original equation, I'll do the first one. 4 plus, who's got the second term? Abe, read it off your paper.
Wait, did everyone leave?
Okay, don't read it off your paper.
It's really
Just
fun.
mentally plug it in. Cotangent of pi over 3 is?
Me, 0?
Whoa, whoa,
0.
whoa.
Yeah.
What?
Pi
Whoa, whoa, whoa.
over, pi over 3, that's 60 degrees. Oh.
Run out of gas.
Okay, I'll give you a hint. It has a radical 3
Oh
in
yeah,
it.
radical 3.
Oh!
No. It's 1 over radical 3 minus 2 times cosec. Abe, redeem yourself. Cosecant pi over 3. Just do sine pi over 3 and huli.
This is for 60.
Yes.
2 over pi, 2 over 3, radical 3.
Okay.
Hey, forever in the video. Forever in the video.
And then of course you need to simplify this. So let's do. I'm just going to do this quickly. Minus 3 over root 3. So that's 4 minus root 3. That's a pretty decent answer. 4 minus root 3. Can you repeat this tomorrow? Because you're going to have to. Or just take the minus 8. I mean, choose a darn good score.
I got that.
Wait, were you here 1 minute ago? You gotta memorize the 6 trig derivatives and x to the nth power plus the product and the quotient rule. If not, say goodbye.
Goodbye, world.
5 or 1 bar.
35. No, for real, it's pretty much all over. Just write your name and hand it in, man. 35. Hey, I think this, we're gonna see this one on the, hey, you guys are picking the right ones.
We're welcome.
Okay, it says compute the second derivative. Compute the second derivative. So first, you must do the first derivative. Hui, 2.
Negative cosecant x cotangent x.
Okay, good. But then, now if this problem is worth 6 points, do I give you 1 for that?
No.
Yeah.
Nah, I don't think so. I don't think so.
6.
You got half of
That's just regurgitating what you're supposed to know already. Like if you write on your paper 2 plus 3 equals 5, I'm gonna give you 1 point.
Yeah.
I don't think so. Okay, now the second derivative. Well, this negative sign is a constant, so you throw it on the side like an unwanted pet. And then I see a product here, so you need to use the product rule. Did you guys use the product rule?
Yes.
Tell me, Tren! If that's really your name.
Cosecant x,
Oh, okay. Always gotta be different, don't you?
cotangent x.
Okay, that's just wrong.
Cosecant
just being
x,
different.
cotangent x.
Okay, remember how the product rule works. Derivative of the first, leave the second one alone, and then you leave the first one alone, derivative of the second.
Derivative of the first.
Yeah, you just
Isn't it cosecant x, cotangent x?
No, it's not.
Wait, yeah.
It's negative.
It's negative cosecant
Oh,
x, cotangent x. You know how much that negative sign is gonna cost you? Minus 2.
Oh, I distributed the negative, so.
Oh.
Fatal error.
Okay, derivative of the first, leave the second one alone.
Cotangent plus negative cosecant x, negative cosecant square x.
Okay, but then I threw the negative on the side like an unwanted pet. But it's up to you. Now, some people, like Tran, you know what Tran did? He incorporated, he went like this, he put the negative with this one, and then he did the product rule. And that's perfectly fine too. As long as you do correct mathematics, you will get the problem correct. Now, let's simplify this thing. Now distribute the negative sign. Cosecant x, cotangent squared x, plus cosecant cubed x, and then you can factor out a cosecant x, and then you get cotangent squared plus cosecant squared. Hey, you somebody.
1.
Wong, you somebody.
1.
No. Yoshida. You somebody. Kamura. Owen. Oka. It stops at Lamachane. Lamachane.
-1.
I tricked you, that's nobody. This is the answer. No. Cotangent squared plus 1 is cosecant squared. Come on, are you guys really that fool?
Yes.
Yeah.
No, it's.
Okay, you guys better brace for impact on tomorrow's test, I guess, because that's what I'm feeling. There's gonna be
Bring on
impact.
second.
There's gonna be impact. Jeez.
That was me.
Whoa! Whoa! Concussion!
My neck is sore now. Oh gosh. 36. Okay, where's, okay, let me see over there.
Man, that was me.
36. Oh, you guys are picking the right problem. Pretty sure you can see this one on the test. Why? Now, you guys are 8 BC, so it doesn't matter if your variable is theta, right? Because in AB, you know what I tell them? Just change the theta to x. But this is BC, you gotta get used to theta because in the third quarter, we're gonna do the calculus of polar curves. So you well, if you didn't want that, then just go AB and then I'm the big man in class.
They don't do polar curves in
No,
AB?
we don't do polar in AB. You gotta wait for second semester calculus to do that. Then you can take it in college. They can take it in college, but they're gonna have a professor that can barely speak English.
No.
Okay, so let's do the first derivative. I see a product. I'm going to use the product rule. Ishihara, read it off your paper.
No.
I'm going to do it now then. No, for real. You guys, some of you are going down hard tomorrow. I'm gonna clutch up. Derivative of the
One.
first. Okay. Times the second.
Secant squared x.
No. You just did a triple fatal
Oh.
error right there.
110
You gotta use the product rule. Derivative of the first,
Yeah,
leave
yeah.
the second one alone.
plus theta times secant squared x.
Okay, very good. No points for that. Now I'll give you 1 because you have to use the product rule. Now it says find the second derivative. Now, I'll do the first one. Secant squared theta. That's just regurgitating, that's why. Now, over here, wait a minute, Mr. Park, this is secant squared. Well, isn't secant squared the same thing as secant times secant? Yeah, but Mr. Park, there's like 3 things. Well, just use the product rule, extend it for 3 things. Now, did anybody figure it out? Who? Did you figure out the product rule when you have 3 things? I saw a hand go up back here. Tran?
I don't know if I did it right, but
Okay, so think about it. How do you do the product rule for 2 things? Derivative of the first, leave the second one alone. Then you do the derivative of the second, leave the other one alone. So just by common sense, Tran, impress me.
1 secant squared x theta plus I don't know what it did.
Okay, I'll tell you how it works just to save time. Take the derivative of the first, leave the other 2 alone. Then you take the derivative of the second, leave the other 2 alone. Then you take the derivative of the third one, leave the other 2 alone. Doesn't that just make sense?
Secant
Otherwise, if you can't extend it to that, then group these together. Gorilla times banana, and then do the product rule, right?
secant
It'll come out. So, continue on, now that I told you derivative of the second.
secant
Secant theta, tangent theta, leave the other 2 alone. Sorry. And then, if you're smart, oh, Mr. Park, it's the same thing. So when I take the derivative of this and leave the other 2 alone, you just go get another one, so then you just put a 2 there. Wham! Yeah! You guys understand what I'm saying?
Mr. Park high kick.
Landon
That's pretty high. That's pretty high for
Mr. Park
my
is
age.
higher.
I think I can go higher.
Try to go higher.
Not now. Okay, so let's simplify this.
Zord pants.
Wait. Okay, so I got 2 secant squared theta. I should leave the simplifying to you guys. Plus 2 secant squared theta tangent theta. Except there's a theta there.
Zord.
No. And I factor out a 2 secant squared theta, and you're gonna get 1 plus theta tangent theta, you nobody. There you go.
I got the answer.
Can you repeat this tomorrow? Like, what I'm probably gonna do, change the tangent to a secant. That would be a good problem, I think.
All hell.
All
No,
hell will break
this-
loose.
You're BC, people. Like, if you were AB, I'd just say, you're not gonna get anything this hard, because we're AB, but we're BC. You are gonna get things this hard. Next, 37. We're in trouble.
These are problems on.
Writing to learn. Okay, this problem is on the test, but this is a watered down version of the one you're gonna get. But x plus, no, we already know how to do this. We did this in previous sections already. Okay, I'm just gonna tell you, it's gonna say find the value of b so that the function is differentiable. Now, differentiable means not just continuous, but also smooth. So, how do you make sure the function's continuous? If you plug in 0 for x here and 0 for x there, you gotta get the same number. So if I plug in 0 for x there, you get b. Plug in 0 for x there, you get 1. So that means b gotta be 1 in order for this function to be continuous. Now what about differentiable? Well, in order for the graph to be smooth, again, remember, the left-hand slope and the right-hand slope gotta be the same. So you gotta compute derivatives. What's the derivative of the first piece? 1. What's the derivative of the second piece? Negative sine x. So if I plug in 0 here and 0 there, they gotta be the same. But in this problem, you get 1 is equal to 0. No can. So this function will never be differentiable. It only can be continuous if b is 1. But don't worry, tomorrow you're gonna get 1. So do you guys understand what you need to do?
Yeah.
You gotta plug in the number into here and here, they gotta be the same. And then after you take the derivative, you gotta plug in the number here and here, and they gotta be the same. The left-hand slope and the right-hand slope gotta be the same. But in this case, it's not.
So is that this
So,
one?
so the answer for this problem is, it's continuous when b is 1, and it will never be differentiable. Because the left-hand slope and the right-hand slope will never be equal. All right, 37, and then finally QQ24.
There is no 4.
Oh, that's wonderful. QQ2. Who's writing these things on the board? Yes.
We've never done
QQ, there is a 4.
No,
Was it a
it's 1, 2,
sign?
3.
It wasn't assigned. Are you serious? Are we really gonna spend time on this?
No.
Over QQ? Are you serious?
No, it is.
No, I'm gonna do it.
Yeah.
Are you serious? Okay, first derivative. Negative sine x plus secant squared x, just regurgitate. Second derivative. Now, secant squared is the same thing as secant times secant, right? So you're gonna have to use product rule. So the derivative of this is negative cosine x, and then you better product rule-atize this, otherwise that's a fatal error. Derivative of the first, except it's secant x, tangent x. Leave the second one alone, but what did we just learn? Since it's the same thing, just times it by 2, because you're gonna get the same thing again. I will leave the simplifying to you, and then you guys can pick out the answer, because that's just multiple choice. Right? So when you see a secant squared, to compute the derivative, you gotta multiply them together and use the product rule, unless you use the chain rule, which we're gonna learn in a few minutes. Yoshida. No, that's the next night's homework. You are not allowed to use the chain rule on tomorrow's test, even though I'm gonna teach it to you now.
Because we don't know.
No, you do know. Okay, if you want to use it on tomorrow's test, you can. But I have a feeling you're probably not gonna do tonight's homework tonight. I have a feeling. You're gonna spend time doing the practice.
Oh, yeah, she does have
You can, but then you probably gonna just take off like.
Okay, so today's lesson is the chain rule. This is section 4.1. This is the next chapter. So finally, Yoshida, you get your wish. The chain rule. Now I'm trying to find a way to speed this up.
Let's make videos.
This is a video. Okay, what if you had this, x squared plus 1 cubed? Write down, the only way we can compute this, the derivative of this, is to multiply it out, right? Because you cannot just do this, right? Can I just think of this as box cubed, and so the derivative is 3 box squared?
Oh.
No, if you did that, this would be a fatal error. So you know what? Just to save time so we can talk about the problems I want to go over on tonight's practice test, I'm just going to state the chain rule. Here's the chain rule. If you have a function that is a composition of functions, like one within the other, then to compute the derivative, you get f prime of g of x times g prime of x. This is the chain rule right here.
We do this.
Huh?
We do this.
No, we didn't do this in PCH. What does this mean, Mr. Park? Okay. Well, anytime you have like one function embedded in another one, like this right here. So if this function is going to be f of g of x, what is f and what is g? Tell me.
G is x cubed.
What is f? What is the outer function?
Oh, x cubed.
X cubed. And then what is g?
X squared plus 1.
X squared plus 1. So do you guys see,
Good job, Tran.
Lamachani, that if you take this and plug it in there, you get this? If I take this and plug it in there, don't you get this?
Yeah.
Let's apply the chain rule now. So the chain rule says to take the derivative, it's f prime of g of x. So first of all, what is f prime? What's the derivative of this? 3x squared. Okay, you know what? Let's just do this first. F prime of x is 3x squared. But then you have to plug in g of x into that. So what happens if I take g of x and plug it in right there?
3.
You get 3x squared plus 1 squared. Hey, that's the thing we wrote first. Yeah, but that's wrong. Times, and here's the most important part of the chain rule, you gotta multiply it by the derivative of g prime, of g. So if this is g, what is g prime?
2x.
2x. There you go, that's the derivative. That is the chain rule. Now, some of you might notice something here. Oh, so Mr. Park, if you have like box cubed, then to take the derivative, you can't just go 3 box squared, right? You got this extra thing there. I need to multiply that by, where did this 2x come from?
Derivative.
The derivative of the box of the inner function. There you go, and that is the chain rule. So the chain rule says,
I remember the box.
yeah. So here, let's do another one. So let's see if you guys got it. So what if you had cosine x to the 5th? Cosine to the 5th x.
5.
Now, whenever you have a trig function to a power, I would highly suggest you rewrite it as that. So that you can clearly see that you have box to the fifth, right? So, how do I take the derivative of box to the fifth? Can I just go 5 box to the 4? No, that would be a fatal error. You gotta use the chain rule and multiply this by the derivative of the box, which is
Negative
negative sine x. That's right. You guys see how the chain rule works?
Yeah.
Okay, let's do one more.
Do they teach it with the box method?
No. That's how I teach my AB students, box method, but it works for ABC too, right? Okay, y equals square root
Genius.
of secant x plus tangent x. Let's kick it up a notch now.
Box.
Well, isn't this the same thing as secant x plus tangent x to the 1/2 power? So what do I see here? I see box to the 1/2.
1/2
Okay, so how do I take the derivative of that? Can I just go 1/2 box to the negative half?
plus times.
No! Then you gotta multiply it by the derivative of the box, the inner function. What's the derivative of this inner function here? Secant x tangent x plus
secant squared x.
Very good. Now, if I'm probably going to give you a problem like this on the next quiz, and then you write that down on your paper, you're only going to get 2 out of 4 because it's not simplified. The other 2 points comes from can you simplify this? Well, isn't this the same thing as 1/2 secant x plus tangent x to the negative half? What can I do with this critter here? You can factor out a secant x, and what's going to be left? Tangent x plus secant x. Oh! So your final answer going to be 1/2 secant x square root of secant x plus tangent x. That's the final answer. Do you guys see it?
Yeah.
Because this is the same thing as that, right? And then if this is to the first power, you add the exponents and you get 1/2 power, which is the same thing as square root. See, so again, what's the hard part of all of this? It's not the calculus, it's the pre-calculus. Okay, we gotta kick it up a notch.
What did you just say?
No, we're not even close. Let's kick it up one notch. Y equals x over square root of x squared plus 1. Now let's compute the derivative. Now yes, you could use quotient rule if you wanted. So there's 2 things you can do. You can use the quotient rule, or would you rather rewrite this as x times x squared plus 1 to the negative half, and then do the product rule? It's up to you. Both ways it's going to come out. It doesn't matter. It's like eating oatmeal with blueberries or oatmeal with strawberries. It's just going to come out no matter what. So which one? Blueberry or strawberry?
Strawberry.
Okay, if I were me, I would eat the strawberry. So what do I see here? I see something times something. I'm going to use the product rule. Derivative of the first, leave the second one alone. Then you leave the first one alone. Now, what do I see as the second one? I see box to the negative half. How do I take the derivative of box to the negative half? Negative half box to the negative 3/2, and then the chain rule times the derivative of box.
2x.
So you always got to remember, you got to multiply by the derivative of box. Okay, now that's 2 out of 4 points. Now we have to simplify this. Well, this 2 cancels that 2. Now this is why we did these problems in PCH last year. Here's the first term. Here's the second term. What can I factor out?
X squared.
X squared plus 1. Now you got fractional exponents. Negative 3/2. You always factor out the smaller of the exponents. In fact, I think this is the exact same problem I had on the PCH worksheet. If I factor this out from this, what's left?
X squared.
X squared plus 1 to the what power?
1.
Very good, to the 1 power. How come?
You
Because when you multiply, you add the exponents. Negative 3/2 plus 1 is negative half. Okay, and then if I factor this out from that, what's left? Minus,
1.
no, this x and x squared. Oh, but this x squared cancels that x. In fact, I think I'm doing one of your homework problems for you. So the final answer is just x squared plus 1 to the negative 3/2. That's the final answer.
Box that.
Box that, that's the answer. It's pretty nice, yeah? In fact, yeah, I think that's one of your homework problems. Okay, you guys think you're good, yeah?
zero. How's the clock structured?
It's alright. Y equals, I'm trying to think of a problem. X squared plus 1 to the 4 times 3x plus 2 to the cube. Well, what do I see here? I see something times something. That means you gotta use the product rule.
I see box.
Okay, so here we go. How does the product rule work? Derivative of the first. Okay, let me call up people. Moriguchi, derivative of the first one. I see box to the 4.
4 x squared plus 1 to the third. And then times 3.
Okay, is the derivative of box to the 4 just 4 box cubed? No, what's the most important thing? The chain rule. You gotta multiply by
The derivative
the
of the box.
derivative of the box. What's the derivative of the box?
2x.
Yeah, so right there. This is the difference between -0 and -8 right there. No, I'm serious. If you're gonna use the chain rule, you gotta use it correctly. So that's the derivative of the first. Leave the second one alone. Now you leave the first one alone times the derivative of the second one. What's the derivative of the second one? Choi! I see box cubed.
3 times 3x plus 2 squared times
The derivative of the box.
Oh, Troy.
3.
3. See, that's why we gotta practice. That's why we have to practice. That's why you have a whole bunch of chain rule problems to do, because you guys gotta get used to multiplying by the derivative of the box. Okay, now what? Now you gotta simplify.
Oh boy.
What can be factored out? X squared plus 1 cubed and 3x plus 2 squared. So if I factor that out, what's left? Hirono.
For 8x times 3x plus 2
Plus.
plus x squared plus 1 and 9.
Very good. Can I leave my answer like that? Yeah, except -2. Because you have to simplify what's inside here. So if you distribute the times, what you gonna get? 24x squared plus 16x plus 9x squared plus 9. So your final answer will be x squared plus 1 cubed, 3x plus 2 squared, 33x squared plus 16x plus 9. You must have your answer in factored form because now you're going to make number lines. Now you can make number lines. But on the homework, just compute the derivative like that. Everybody see? So again, anybody can learn the chain rule, the product rule, the quotient rule, but then you got to be able to simplify it and then make a number line. Okay, we got to kick it up a notch. So can we apply the chain rule to the trig ones too? Like, what if you had just a sine of x squared, sine box? So we already know what's the derivative of sine x? No, it's cosine x. So can I apply that to the box? So the derivative of sine box is just cosine box?
-8 times.
No! Again, you gotta apply the chain rule. You gotta multiply by the derivative of the box, which is 2x. That's why I left the space in the front.
Oh.
You guys get it? So yes, you can apply it to any function as well, but you gotta remember to multiply by the derivative of box. Okay, so let's do another one. What about tangent 5x? Well, we already know the derivative of tangent x is secant squared x. So is the derivative of tangent box secant squared box?
No, fool.
No, because I left the space in the front for the
5.
derivative of the box, which is 5. So, what time is it? Yeah, we got time. So now let's revise our list. Let's revise our list. That's why if you look at, you guys didn't look at my website yet. Whoa, whoa. So instead of x, what's the derivative of x to the nth power? N x to the n minus 1. So that's why if you did look at the list of derivatives on there, instead of an x there, we put a u. U stands for box. If you have box to the nth power, is the derivative just n box to the n minus 1? No! Then you gotta multiply it by the derivative of the box. That's the chain rule right there. You gotta multiply by the, now, can you see that when you have y equal cosine x? So the derivative of cosine box is negative sine box, but then what happens when you multiply by the derivative of that? You get 1. But most of the time it's not gonna be 1, so that's why you have to always adjust for the derivative of the box. Okay, so what's the derivative of sine box? Is it just cosine box?
No.
No! Then you gotta times by the derivative of the box. What about cosine box? You guys don't have to write this down now, it's on the website, just a list of derivatives. It's right there. Is the derivative of cosine box just negative sine box?
No.
No, you gotta multiply by derivative of box. What about tangent box? Is it secant squared box? No, you gotta multiply by derivative of box, and so forth. Do I have to finish it?
No.
No, I'm doing it already. Times the derivative of box, and then secant box, tangent box, times the derivative of box. And then cosecant box would be negative cosecant box, cotangent box, times the derivative of box. That's the chain rule. So you see all of this stuff right there? The derivative of box, that's the chain rule. That's the chain rule. Okay, now, let's do a tough problem where you have box within box within box. So something like this. Y equals the square root of sine squared 3x plus, give me a number. 5.
Oh.
Okay, so this problem will show that you understand the chain rule, that you could have actually box within box within box.
Oh, that's insane.
Okay, so before you set up this problem, you should be thinking, well, square root is 1/2 power. So inside you would have sine squared 3x. But remember I told you guys when you have a trig function to a power, write it like this so that you can clearly see that it's box squared. After a while, you guys will get the hang of it and you don't have to do it. But when you first learn it, that's what you should do. So here we go. Let's take the derivative. Now, what do I see? I see box to the 1/2 power. How do you take the derivative of box to the 1/2 power?
1/2.
Can I just go 1/2 box to the negative half?
No.
No! Then you gotta multiply this by the derivative of the box.
Oh no.
Okay, so now just focus your attention on this box right here. Now what do I see? I see box squared plus 5.
Oh,
2.
How do I take the derivative of box squared plus 5? Now box squared, can I just go 2 box to the first?
no.
No. 2 box to the first
Oh my goodness.
times the derivative of the box. But
Oh
what is that?
God.
What is that box?
3.
Sine box.
Wait.
What is the derivative of
Wait.
sine box?
Oh god.
Cosine box times the derivative of that box. And then of course plus 5, the derivative of 5 is 0, right?
Yes.
Boom! That is the correct answer, and I will leave the simplifying to you. Pretty much all you have to do is cancel out the 2's in this one. You really can't do much with that. So do you guys understand? So that's why if you just break it up into pieces, then you just keep asking yourself, box to the half. But what is this box? Box squared plus 5. So you take the derivative of that. But then when you take the derivative of this box, you have sine box. The derivative of sine box is cosine box times the derivative of that box. So in this problem, actually you have box within box within box within box. So that's kind of what you had there. That's about as hard as it gets at BC.
The test is gonna be $5.
No, I think 4 boxes is enough.
4?
Okay, so tonight's homework is just practicing the chain rule. Yoshida.
Could you have a problem where it just infinitely goes on, and then you have like root x plus root x plus root, and then take the derivative of that?
Oh,
Yeah,
test
but I'm
question.
not gonna give you that though.
Oh, I thought it would be a test.
But now that you said that, I'm thinking of a problem now.
Oh.
Find the nth. Oh, you're already gonna get a problem with that. Find, write a formula for the nth derivative.
Can't you just have to do that?
What?
Okay, now, here's one way to write the chain rule. Look, how did I write the chain rule the first time? If y is equal to f of g of x, then the derivative is f prime of g of x times g prime of x. This is one way to write the chain rule. But another way to write the chain rule is like this. dy dx. Now, see, the good thing about Leibniz notation of the derivative, you can treat it like regular fractions. So, like if you're doing parametric equations, you can divide the top and bottom by dt. So you would have dy dt over dx dt. Remember parametric? And then, of course, that can be written as dy dt times dt dx. Right? Because when you divide by a fraction, that's like multiplying by the reciprocal. And that is why we call this the chain rule, because look, it's like a chain. Look, dy dx, isn't that equal to dy dt times dt dx because the dt's cancel out? You can treat it like regular fractions. But see, this is just a small chain. Here, let me give you an example of a longer chain. dy dx is equal to dy dt times dt dq. Right, you see dq a lot in physics, right? Because q is charge, yeah?
Sure.
What's physics?
Yes.
dq dm times dm dk times dk dx.
Donkey Kong.
So there you go. This would be an example of a longer chain because what? These cancel out, these cancel out, these cancel out, these cancel out. What do you have? dy dx. So Leibniz's form of the derivative is really nice because you can treat it like regular fractions.
Wait, so how does that even work?
Curry Master Swan.
Is it like
Okay, here, I'll give you a problem that you can see on the next quiz.
Is it like derivative of y with respect?
Here, no, I'll just tell you. Yeah, so this is the derivative of y with respect to x. This is the derivative of y with respect to t. This is the derivative of t with respect to q, and so forth.
Okay.
Okay, in fact, you're gonna get a problem like that tonight somewhere. Okay, here. If dy dt is equal to 3 and dx dt is dm dt is equal to 4 and dm dx is equal to 5, compute the value of dy dx. That's a problem we're gonna see in the next quiz. Well, you can treat this like fractions. Isn't dy dx the same thing as dy dt times dt dm times dm dx? Because these would cancel out and those would cancel out. See, it's a chain. See, chain. Okay, so what is dy dt equal to? 3. What is dt dm equal to? Well, if dm dt is 4, what is dt dm? It's 1/4, that's right. And if dm dx is 5, what is dm dx? 5. Look at 15 fourths. Boom! Chain rule, baby.
That's what I'm talking about.
So there's 2 ways of writing the chain rule. One is like this, but usually when we write it, we don't write like that. We write it like this. Like that. And that's another way to write the chain rule. Okay, so tonight's homework is chain rule, chain rule, chain rule. However, tomorrow is the test, so you gotta prepare for that. We got 10 minutes. So if I were you, it looks like some of you are still in the embryo stage only. So if I were you, I would study the heck out of this thing.
Do you post this on your Mr. Park map?
Yeah, I'm going to after it's done. Okay, now look at that. Okay, number 1. It says, when is the derivative greater than 0? I think you guys can do that. You take the derivative and make a number line. Number 2, find the derivative. You just have to do some product rules in there. I think you can do that. Oh, but look at number 3. What the heck is that, Mr. Park? I'm going to do a problem just like number 3a right now. What is the limit as h approaches 0 of tangent x plus h minus tangent x all over h? In fact, let's put a square here to kick it up a notch. Hey, you somebody. What is, in fact, whenever you see limit as h approaches 0, what are you thinking? Derivative. Skip to the next problem? Or, hey, that's the definition of the derivative. Yes, this is the definition of the derivative. What function are you taking the derivative of?
Tan squared x.
That right there, because this is f of x plus h minus f, this is f of x. So all you have to do is simply take the derivative of that.
Oh, chain rule.
Yeah, but we didn't learn it.
Wait,
So-
you said you could use it on the.
Okay, you can use it on the test, but since we didn't learn it,
We just learned it.
see, that's the dilemma I have when I write problems, because I don't want you to use it. Okay, let's just use the chain rule then.
Wait, so we're,
So we can use it.
Yeah,
on
you
the
can
test?
use the chain rule. I'll let you use the chain
well,
rule.
we get points too.
Yes, you'll get points. Okay, so what do I see? I see box squared. What's the derivative of box squared?
2 to
2 box to the first
times.
times the derivative of the box, which is
Secant squared
secant squared x. There you
Oh,
go.
box up.
Okay, that's correct. Now look at 3b and C. Hey, those are definitions of the derivative.
Oh, chain rule
But
again.
remember, there's also, oh my goodness. Okay, let me do one. Limit h approaches 0, cosine pi over 2 plus h minus cosine pi over 2 all over h. Hey, you somebody. Isn't this like how you compute the instantaneous rate when x is pi over 2? See, the only difference between this problem and this problem, see, normally you have an x there, but now there's a number there, so what does that mean?
Just derivative.
Yeah, you're computing the derivative at that particular value of x. So what you should be thinking in your head, the function is cosine x. What's the derivative of cosine x? Negative sine x. But since there's a number there, you have to plug in that number into the derivative to compute the instantaneous rate of change. And so your final answer gonna be
Negative.
-1, that's right. You guys see? You guys, this is all of this. In fact, the test looks almost exactly like this. That's why I give a practice test like this. And then what about C, Mr. Park? What the heck is this? This is the other definition of the derivative. Okay, here. What's the limit as x approaches 3 of f of x minus f of 3 all over x minus 3 if the function is, give me a function.
X to the fifth.
No,
X
no.
to the third.
X to the third.
Okay, let's do x to the third. Why, is that the same as that?
No,
No,
it's
it's
X to the fifth.
Oh yeah, so this one's easier. Okay, so A,
Use some.
you somebody, that's equal to f prime of 3. Remember, there was a homework problem, but you guys probably don't remember it. This computes the instantaneous rate when x is 3. So all you have to do then is take the derivative and plug in 3. So what's the derivative of this? 3x squared, plug in 3, 27. Bam. That's how it goes. So what I want you to do in these problems is to recognize that these are the definitions of the derivative. Now, if you want to do it the long way and compute the difference quotient and look for friend and acquaintance, you can, but it's a lot faster to simply take the derivative and plug in the number. Okay, what other problems would you have problems with here? Number, no, come on, you can do that. Okay, I'm gonna tell you right now, you better be able to tell me when the particle is speeding up and slowing down. How do you do that? You gotta make a number line for the velocity, and you gotta make a number line for the acceleration. You're gonna do that tomorrow, just like you did on the homework. Okay, here's a problem that my AB students have problems with, number 8. Why don't we do that on the board? Every year they have problems. I'm guessing some of you would have problems on that. Okay, this problem is on the test, probability 1. Y equals x cubed plus ax squared plus bx plus c. Find the values of a, b, and c so that this graph passes through the point 1, 1, and it is tangent to the line y equal 5x minus 3 when x is 0. Now, if I were you, I would draw a picture to help me understand this problem. This is a cubic function. What? Like that. It passes through the point 1, 1, I don't know, just make it 1, 1. And then, when x is 0, right there, the equation of the tangent line is y equal 5x minus 3. Find the values of a, b, and c. Well, if the graph passes through the point 1, 1, what do you think I'm going to do with that? This is like SAT. You plug it in. So if I plug in 1 for x and 1 for y, what are you gonna get?
1.
1 equals 1 plus a plus b plus c, which of course means a plus b plus c equals 0. Now, you can probably guess what's gonna happen in this problem,
Three
yeah?
equations.
You can write 3 equations, 3 variables, and you
Matrix.
solve. Okay, there's 1 equation, I'll give you 1 point for that. Check, 1 point. Okay, now we need to write another equation. Now, do we know another point that the graph passes through? Yeah, this one's 0 something, except Mr. Park, I don't know the something. Yes, you do, Moose Bread,
Well, just
because
plug it in.
both the line and the graph pass through that point. So since this is the equation of the line, if I plug in 0 for x, you get -3, so you do know another point. I can plug that in, and you're gonna get -3 equal 0 plus 0 plus 0 plus c. Check!
Oh,
You
fancy.
get another point. We just found out. Don't worry, tomorrow's test not gonna be this easy. I'm just not gonna make that point a 0, right? Because if I make it like 2, then not
Why would you do that?
because we're BC. Even in AP, I don't make it a 0. Okay, finally, I need one more equation, Mr. Park. Well, it must have something to do with the derivative, since that's what we're studying. Now, doesn't the derivative tell you the slope of the tangent line? Well, here's the tangent line. What's the slope of this line?
5.
Oh, so when x is 0, the slope got to be 5. And how do you compute the slope of the tangent line? You take the derivative. So, you take the derivative of this equation, and what do you get? 3x squared plus 2ax plus
b
plus the
0.
derivative of a constant is 0. So, here's the derivative.
Equal to
When
5.
the x coordinate is 0, the slope is 5. So that means when I plug in 0 into the derivative, you gotta get 5.
Oh, B is fine.
Well, if I plug in 0 into there, you get 0 plus b equals 5.
Oh,
Check.
you're
Now,
like
see
the
how
problem.
it's all easy because of
Box that.
this 0.
You actually only.
Okay, so tomorrow, you're gonna get, I'm telling you right now, you're gonna get the same problem except not gonna be 0. So you're gonna actually have real 3 equations, 3 variables to solve. This is fake 3 equations, 3 variables.
It's real.
So does everybody understand that? Okay, and then let me look at any of these. Oh, look at number 9. We got 3 minutes left. I'm looking at these other ones. Yeah, let's do number 9 for funsies then. Number 9. You guys better do this again on your own now. F of x is equal to cosine squared x plus sine x. Between 0 and 2 pi, when is the derivative less than 0? So, yeah, you gotta find the derivative, and then you gotta make a number line. Okay, now, how do I take the derivative of this? You should rewrite that as cosine x quantity squared, because, so are you guys gonna really use the chain rule tomorrow then?
No.
Or are you gonna rewrite that as cosine times cosine and use the product rule? I don't really care what you do, because it's gonna come out the same. It's just strawberry oatmeal versus blueberry oatmeal, it's gonna come out the same. So what?
Strawberry.
So tell me what you guys are gonna do tomorrow.
2 cosine x.
Okay, okay,
2 cosine.
I'm gonna rewrite it as cosine times cosine, let's use the product rule. Derivative of the first,
Negative cosine.
leave the second one alone. But since it's the same thing, put a 2. Plus, the derivative of sine is?
Cosine.
Okay, there's the derivative. I need to know when this is less than 0. So, I need to factor this thing. So what can be factored out?
Cosine.
No, factor out a negative cosine x, so the first term is positive. So what's left? 2 sine, it doesn't matter. There you go. So, you make your number line. What makes that thing 0? Pi over 2, 3 pi over 2.